Hello everyone. Today we will be presenting our topic, parallel models for predictive maintenance and fault detection in gas turbines. Modern gas turbines generate hundreds of sensor channels, often streaming in the kilohertz rates, which adds up to true big data workloads. But today, most fleet operators still rely on a combination of simple threshold alarms, data historians, and big data clusters like Hadoop or Spark to analyze that information. These systems work well for long-term storage and offline analytics, but they struggle with real-time detection. Threshold alarms are too simplistic to catch subtle multivariable patterns, and Hadoop or Spark pipelines introduce minutes to hours of latency. Because of this, early-stage faults are often missed, and operators don't see the warning signs until the problem is already developing.
Our original idea was to study parallel versus non-parallel processing for gas turbine data, but as we looked deeper, we realized that the real issue wasn't the processing method, it was the delay in today's systems. Most analytics happen after the data is stored, which is way too slow to catch faults. So then sticking with our idea of parallelism, we came up with the idea of adding a small edge computing node right next to the turbine's control system. This edge node processes data right away by using multiple CPU cores for parallel analysis, sending important statistics to operators. This would remove most of the delay that helps detect issues much earlier.
With an edge computing node, the improvements are pretty dramatic. First, latency drops from hours down to just seconds because the data is analyzed right where it's created. Second, fault sensitivity increases. Instead of relying on single value thresholds, the edge node can look at multivariate patterns, which makes early fault detection much stronger. Third, we see a major reduction in bandwidth. Instead of streaming all the raw sensor data, the system only sends compact features or alerts, taking bandwidth from very high to very low. And for operators, awareness goes from delayed to real time, which means they can respond to issues much sooner. It's important to note that while edge computing technology does exist today, deploying this exact architecture inside a gas turbine control environment would be challenging. So our expected outcomes are based on existing research and other industries that have already been implementing edge node designs. Thank you for listening. Feel free to ask any questions.